The next thing that we need to talk about is the domain and range of these exponential functions. So remember, domain is the left to right, and range is the up and down that a function can go. So looking at these, let's take our example that we used on the last page, y equals 2 to the x power. And we need to basically see how far left can this go, how far right can it go, and how far up and down can it go. Well, we know basically the rules for domain is that you can't have a 0 in the denominator. So let's plug in some values and basically see what happens. Do we get any like zeros in our denominator here? So if we had like 2 to the first power, well, that's just 2. 2 to the 0 power, okay, that's a weird one. Plug it in, and again, remember anything to the 0 power, doesn't matter what it is going to give you a value of 1. And then what about negative exponents? And maybe it's been a while, but for negative exponents, it's just 1 over whatever it is to the positive exponent. So that just equals 1/2. If it was 1 over, let's do a second example in case we need a bit of a refresh on negative exponents. This would just be 1 over 2 to the second, which is 2 to the second is 4, so 1 over 4. So it looks like for values that we can plug in, all positive numbers work. So those are the x values that we plugged in, and remember that x goes left to right. So it looks like any real number works. But maybe you notice something here with our pattern. And let's see if we put this on a graph. So when x equals 0, we had a y value of 1. When x equals 1, we had a value of 2. When x equals -1, we were at like 1/2, then we went to 1/4. And it looks like we're approaching the x-axis here. Do we cross it? Maybe let's try a really big number, like y equals 2 to the -100th power. And let's punch that into the calculator. So we'll know that's going to be like 1 over 2 to the 100th. So let's see what this gives us. So 2 to the 100th. So it looks like a really, really, really small answer. So it gave me here scientific notation like 7.9 times 10 to the -31st. So like a whole like 30 decimal points. What this looks like is like 1, 2, 3, 4, 5, 6. Just keeps going like 30 times over. And there's more zeros in there. I missed a few, obviously. But really, 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 really small, but still a positive number. So if we go like all the way left over here, it looks like, again, really, 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 really small, but still positive. So we're actually not going to cross over into a negative number. So it gets really close. It gets so close that you can barely even see it, but it's not going to cross that axis there. So the shape of our function, it kind of like goes up in a curve. And in this case, our range is actually all positive numbers. So positive only. So if we're looking at this, we would never cross below the axis here. This red zone, never going to happen. Can't have those values. But the green zone for our range, our up and down values, anything above that axis we're fine with. And that's going to be true for all functions that are in this form of like 2 to the x power, 7 to the x power. Anything that looks that simplified without anything modifying it, that is going to be the case for the domain and range. But the skill does get a little bit harder because we have these things called transformations that we have to deal with. They're basically shifts. And if we're looking at a function like y equals 2 to the x power, we can move this around. So if this is on the graph, there's a couple different things that we can do. So again, graph a few points here, get the idea of the shape of this. You're going to see it's going to go up like that. And again, never going to cross through that axis. But with our functional form, there are 2 different motions we can do. And we'll do them in different colors. So we can go up and down. And quite literally, that means that we're going to take this red function and move it up or down. So if we add something to it, it's going to take whatever value we had and just add 3 on top of it. So in this case, we'll just go up 3 from this point, 3 from this point, and then our axis actually invisibly moves up by 3 as well. So we're going to see a very similar shape, basically the same thing, it just got popped upwards. So if you add, you go up, and if you, I'll spelled the wrong way. If you subtract, you go down. So that's in blue. So that's one shift that you can have. And if they're asking you for the range now, if they moved up by 3, the range would be any y value that's greater than 3. Again, it's never going to cross below that line, so that's our invisible line. Before we said any positive value for y, now it does specifically have to be bigger than 3. There is another shift, though. So we can go left and right. So again, let's start with our original function. Y equals 2 to the x. And maybe we can draw another graph here just so we don't get confused. And let's see what happens that makes us move left or right. Well, this one is actually a little bit backwards, and this is how I remember it. It's the opposite of what you think. So 2 to the x, this time we're going to make the change to the exponent, and if we add, instead of going to the right by 2, we're actually going to go to the left by 2. So we take whatever this is and just move it 1, 2 to the left, 1, 2 to the left. So you're going to see it's still that same shape, but it's just kind of going up sooner. So again, same basic function, just moving to the left, and then if you do the opposite, if you subtract, you move it to the right. So again, probably should have highlighted this one. This is our transformed function. Again, just a little bit to the side there. So again, if you add in the exponent, you go to the left, and if you subtract in the exponent, it shifts you to the right. Now this does not change your up and down, it just basically shifts it side to side. So if you ever see that, again in the exponent, that's basically the thing that's happening there. The final piece to note, and this does not come up as frequently in questions, but this is just good knowledge to have, generally speaking. It can kind of, I like to call it, get like flat or steep. Again, working with our original function, 2 to the x. The last thing that we're going to see here is if you put a positive number in front of it, so something like y equals 6 times 2 to the x, it's going to be the same function, but again, it's going to kind of, they call it like compressing, but I always think of it just gets a lot steeper. It just goes up faster. So again, same basic shape, but just goes up faster. But if you add something that, again, is like less than that, so maybe like 0.5 times 2 to the x, it would just become flatter. It's still that exponential shape, but it still becomes flatter. So the rules for this one, if we have a value in front of the base that the absolute value is greater than 1, so let's say that a value in front is greater than the absolute value of 1, it gets more steep. And if the absolute value is like between 0 and 1, which basically just means it's like a decimal, it's less than 1, but it's bigger than 0 still, we're going to say it gets kind of like flat. So these are the two kind of rules that we have here for how our functions work. All right, so that is a quick overview of like the shifts and the shapes of these functions and how they work. Again, the big focus for today, though, is going to be moving left, right, and up and down. But as long as you have these skills, you have a pretty solid foundation of what our exponential functions look like. Thanks for tuning in, and get ready for some practice problems.